Hello, you're welcome to my YouTube channel. Thank you for stopping by. Today we are answering this trigonometric question that we are required not to use a calculator. Now let's read the question together. The diagram shows two right-angled triangles, ABC and ACD. Find the value of cos ADC. Now, why did we read the question? Because we want to identify what we are given and what we are being asked to find. What have we been given here? We have two right-angled triangles, ABC and ACD. What have we been asked to find? The value of the cosine ADC. Cosine ADC. Now, the first thing you need to identify on the diagram is what is even the angle, because if we're being asked for the cosine, it means we're being asked for an angle, the cosine of a specific angle. Where's the angle? The angle is ADC. So we are looking for the cosine of this angle here. Now, to find the cosine of that angle, we need to recognize that to find cosine at all, we consider using our SOHCAHTOA. Why are we using SOHCAHTOA? Because it's a right angle triangle. So SOHCAHTOA will be appropriate. If it were not a right angle triangle, then we'll need to consider our sine rule or our cosine rule to find the length of sides or angles there. I hope you understand what I'm saying. Now, so the cosine of ADC, the cosine of any angle at all, cosine, say cos of theta, is given by the adjacent over the hypotenuse. Now, so you need to identify the adjacent of the triangle as regards that corresponds to the angle you're looking at. As far as this triangle is concerned, the adjacent of that angle there is side CD. And the hypotenuse of that triangle is the side AD. Now, we've been given CD in the question, but we do not know what AD is. Not yet, but we can find it. In our bid to find AD, we need to go down and look at the other triangle. Yes, we're talking about triangle ABC. In triangle ABC, we are given our side BC and the angle at A. But if you take a close look at that triangle, you will notice that if we find AC, which happens to be the hypotenuse of triangle ABC, is going to help us find the hypotenuse of triangle ACD. Getting confused? Just stay with me. So let's try and find the side AC first. Okay, what is AC going to be? If you look at this triangle down here, AC is the hypotenuse. We are given angle 30 here and the side opposite 30. When you have a combination of looking for sine or knowing the sine of an angle, and then you're required to work with the opposite and the hypotenuse. Now, take a look at this angle here. Angle theta here is 30 degrees. So we know that sine 30 should give us the opposite, which is 6 centimeters, over the hypotenuse, which is AC. Now, changing the subject of our formula, we find out that our AC should be equal to 6 over sine 30. Now, here's the game changer. You need to know the exact trigonometric value of certain angles, of angles 30, 60, and 45. I have a separate video. I have made a separate video where you can find how to do this quickly in an exam situation. I also have put up a table for you to remember. There is a relationship there. If you pay attention, there's a pattern to these values. Looking at my table, I know that sine 30 is 0.5 or a half. So AC will be given by 6 over 0.5. And that gives us our AC as 12 centimeters. So let's put that in our diagram. Whenever you find something, please ensure you put it on your diagram. It's going to help you see better how to solve the question. Now that we know what our AC is, the information on our triangle ACD is becoming clearer. Now we know the base of triangle ACD. We also know its height, or we know, as far as that angle there is concerned, we know the opposite and the adjacent. But remember, for our cosine, we need our hypotenuse, which is AD. How do we find AD? You guessed right. You need to use your Pythagoras theorem, because since this is a right angle triangle, by the Pythagoras theorem, we know that the hypotenuse square, that is AD square, is given by the opposite square, which is 12 square, plus the adjacent square, which is 9 square. All right, so AD will be given by the square root of 12 square. What's 12 square? That is 144. Plus the 9 square, that is 81. Again, remember this, your square numbers are critically important. You need to remember them to help you ace your non-calculator paper. 144 plus 81 will give us 225. And the square root of 225 is 15 centimeters. All right, now we know what AD is. We can come back here and answer our original question. We need to find the cosine of angle ADC, and it's supposed to be CD, given in the question, as 9 over AD, which we just found to be what? 15. So our final answer, taking this fraction to its lowest term, will be 3 over 5. Here is our answer. Please note that to answer this question, we have explored our Pythagoras theorem and our knowledge of SOHCAHTOA. All right, please remember you need to know the exact values of certain angles, that is of angle 30, 45, and 90. The trig ratios for those angles. What is the sine of 30, the sine of 60, and so on. Please remember them. If you're in doubt on how to get them, watch the video. This video that I'm putting up here, to help you clarify how to find those values out quickly in an exam situation. Thank you so much for watching. If you have any questions, feel free to drop them in the comment section. See you in the next one. Bye.